Awesome. Welcome to one of the most important section of trigs again. I haven't gone through the knowledge of trigs. Trigs can be represented in form of graphs. This is going to be the same thing in grade 11 and in grade 12. The only thing different would be in grade 11 we have single angles and unit angles, but in grade 12 we have double angles. That's the only thing, but every other concept remains the same. So we're going to try to run through the content, then we sketch and try to understand how to deal with graphs. Sweet. So trigonometry functions. We're going to bring in the knowledge of paper one, just your normal parabola functions as well. We're even going to talk about an asymptote somewhere. So it's important that you use this as well to revise paper one. I'm going to take it quite slowly so that everybody can be on point. I want every slide to make sense to you. All right, so let's start the journey quickly with understanding the foundational basics of a graph. I'm going to start by giving us the general formula of a trig graph. Okay, general formula. Remember we have sine, cos, and what? Tan. So we can write f of x as a sine b x plus p plus or minus, oh wait, I need to say plus or minus p as well. Plus or minus p plus or minus q. So now there are different parameters that I have introduced there. Remember the sine can become what? Cos, and it can also become what? Tan. But the parameters we see there, how many parameters do we see? 4. There's A, there's B, there's P, and there's what? Q. So we could also have this as A cos B x plus or minus P plus or minus Q. We could also have A tan B x plus or minus P. Now we are going to look at the parameters that are labeled here, one after the other. You miss this, you struggle. 1. What is f of x? Y value. We're done. F of x refers to the output, which is your y values. That we know already from paper 1, right? F of x is y. Number 2, A. A is called the amplitude. If you do waves, this mustn't be new to you, especially waves in grade 10. All right, amplitude. What are the points we're going to know about amplitude? A is always positive. Please, always. I'll tell you something shortly. A is always positive. A is equal to the maximum minus the minimum over 2. That's how we calculate it. A is always positive. Maximum minus minimum over 2. A affects the range. A affects the range. So please, I'm going to try to do this in a general way, putting everything together in formulas for you. You just need to know it and substitute where applicable. A is always what? Positive. Top minus bottom divided by 2. A affects what? Range. Look, Let's try something quickly. If I give you f of x is 5 sine x, what is a if you compare it with the general formula? A is still 5, right? What about f of x equals to minus 5 sine x? What is a? A is still 5. This is only a reflected graph. But the A is still what? 5. So don't be deceived. A is still what? 5. A is always positive. And A will affect one thing only. It will affect the range. We are done with A. What's the next one? B. Number of complete circle. Number of cycles. B tells us how many graphs we have in one mother cycle. That B is a number. It tells us the number of graphs we have in one mother cycle. You'll understand what I mean by mother cycle. Mother cycle is what we learned from grade 10. B affects the period. The question is, we must know what a period is. Period is the length of a complete graph or a complete cycle. Let's go through grade 10 very, very fast. Mother graph, which is the original graph. Mother graphs, sine theta and cos theta have periods of 360 degrees. While tan theta has a period of 180 degrees. That's the mother graph. In grade 10, we did that. Sine theta. But we're going to compress it now and put all together. Sine theta, cos theta. That's why when we do general solutions, if you remember, we would say plus k 360. But for 10, we would say plus k 180. General solutions, which we did. Now, how then do we link B and the graph? So for sine theta, or sine B theta, and cos B theta, our period will be 360 over B. And for tan B theta, period is 180 over b. We're going to look at examples. I'm going to explain. I am going to explain. Let me write my tan very well. It doesn't look good as a tan. For sine b theta and cos b theta, period is 360 degrees over b. Remember, what is b? The number of what? Graphs in one full mother cycle. I'm going to take us through this journey very, very slowly. You understand it once and for all, you get it. All right, just a few seconds. A lot of people are just joining in to catch up. This is our first slide. General formula. All right, are we done? Are we done here?
Yes, sir, mate.
Thank you.
When is your birthday?
Are we done here? I need to move to the next slide.
I think we don't give you much the honor in this.
Well, let's just take a picture of this one because I won't wait for you to start from the beginning. Somebody just take a picture and send on the group here so that those who are just joining can just leave some space and catch up on this. Now, I want to quickly explain. We're still on number 3, which is talking about what? B. How to get B. So if I take you back to grade 10 very quickly. If I look at sine theta, if you guys remember what the graph of sine theta looks like. The graph of sine theta looks like this. You have 0, you have 90, 180, 270, and what? 360. Sine 0 is 0, sine 90 is 1, 180 is 0, 270 minus 1, 360. Now, this is what we mean by, that's our sine graph. Please watch this. This is one full cycle. And this is what? 360 degrees. How many graphs do we have here? 1. So if I tell you sine theta, it means B is 1. Because it's saying sine 1 theta. In the space of what? 360. So my period for this is 360. I know it might not make sense now, but just listen to the second part. This second part would validate what I mean. If I have sine 2 theta, what am I saying? I'm saying draw me 2 graphs. You see, this is B. Draw me how many graphs? 2 graphs in the space of what? 360. Don't move out of the space of 360. Let me put that as a guide. Don't move out of the space of what? 360. So look at what it will be. Look at what it will be. 360. Because I must squeeze in 2 graphs there. How many graphs are you saying? 2 graphs. Right? What is the length of one of them? The yellow. Patu, open your eyes. That's my graph. 1. And the second one starts from here. What is the length of 1? It's 180. That is 1 full graph. So it tells me that the period here is what? 180 degrees. If I tell you, check this, if I tell you sine half theta, what is B? Half. What am I saying? In the space of 360, what do you draw? Half a graph. Look at that. In the space of 360, draw what? Half a graph. Do you notice that's half? Where's the other half? It's not drawn, right? But the other half should be here. Which would be another what? 360. And that would be what? 720. Make sense? So what is the period? The length of 1 full graph. 1 full graph is like this. What's the length? 720. Yeah, you still look lost. Talk to me if you are lost. B is the number of graphs that you find in one mother cycle. When I have B is half theta, I'm saying draw only half, but use the space of what? 360. So draw half. That's half the graph. When B is 2, what am I saying? Draw how many graphs? 2 graphs in the space of what? 360. Don't pass 360. When B is 1, how many graphs am I drawing? 1 graph. In what space? 360. So for the first one, for this green one, my full graph is what? 180. For the second one, my full graph is what? Sorry, first one is 360. My full graph for the second one is what? 180. For the third one, this is half. If half is 360, the full should be what? 720. And that's why I gave you the formula that says period. Check the formula. If you know how to use the formula, period is 360 over what? B. For the first one, 360 over 1. For the second one, 360 over 2. For the third one, 360 over half. 720. How are you? 720. Yes, Bokamoso, what's the story? How are you? Your hand is up, Bokamoso, quickly. What's your story? What's your question? So B is the number of complete graphs. Period is, for those of you that do physics, we talk about wavelength. So period is the wavelength of a graph. If I give you this, if I give you sine 3/2 theta, what does it mean? Draw 1.5 graphs in the space of what? 360. So what's the period? What's the length of one graph? Huh? Use the formula quickly, everybody. Use the formula. I need the period. Part 2, I need a period. Don't be using style to write the notes. I need period of sine. I have sine 3/2 theta. Now you are using style to write. Give me an answer. The formula is there. I gave you the formula. It's right there. It's staring at you. You need to make sure you catch up quickly on every step. Don't waste time. Huh? Calculator is not working. So use your head. What's the formula? How do we get it? How do we get period? What's my period? 360 over 3/2, which will give you what? 240. Because 360 over 3 is 120 times 2 would give you what? 240. So that's how you work it out. Please, I need us to be more swift in moving along as quickly as possible. And be able to read that from the graph. It is one complete wave. The length of one complete wave. When we draw, you are also going to see all of those, especially for 10 graph. I'll be combining sine and 10 graph. Let me put a note here quickly. Period. The period of a tan graph, let me put that note here. The period of a tan graph, of a tan theta graph, is the distance between two asymptotes. Between two asymptotes. And I'm sure we are not new to asymptotes. The distance between two asymptotes. So we are looking at all of these variables. We've looked at A. Now we are busy with B. Don't forget, B is the number. So sometimes examiners will ask you to find B. We will see how to get through that once we start looking at activities. Okay. B tells us the number. How many graphs? Don't forget the formula. Period is 360 over B. For sine theta, for cos theta. But for tan, what is it? 180. Takes you back to general solutions. When we do general solution for sine and cos, we say plus k, 360. But for tan, plus k, 180. It repeats itself after every 180 degrees. So here, I was just trying to explain what I mean. Sine 1, you draw one graph in the space of 360. Sine 2, you draw two graphs in the space of 360, which means we have halved it now. The graph is now shorter. Sine half, the graph is longer. If I say sine 3, if I tell you sine 3 theta, what does this tell you? Is it times 3? It means that in the space of 360, how many graphs do we have? 3 graphs. 1, 2, 3. What is therefore the length of one of the graphs? Is this 2.5? Oh yeah. Let me elongate this part. So we're saying draw 3 graphs. 1, 2, 3. That's what it means. So we have the length. Okay, interesting. We have 1, we have 2, and we have 3. And the total distance is what? 360. So what's the length of one of them? 120. Because it's saying 360 divided by the number of graphs, which is what? 3 graphs. All right? So what is this? 120, 120. And again, it's all by using what? Because your B in this case is what? 3. So what is my period? 180 over, 360 over what? 3. And that gives you. Please let me know. I am moving away from B. Are we okay? Any question? Let me know. Thumbs up. You know what to do. You know what to do. Thumbs up. If there is no question, thumbs up, everybody. Okay. Let's go and look at P now. Remember, we said A sine B, X plus P. What is X? X is your domain. We're not going to waste time on that. X is our domain. Let's look at P. What does P tell us? This will be number 4. P. Horizontal what? Shift. Horizontal shift. P must always be in bracket with X. Please take note. It is X plus or minus P. It must be in brackets. Just like our functions, P represents what? Horizontal shift. P represents a horizontal shift. And what do we know? Plus tells you the graph is shifting what? Left. Minus tells you the graph is shifting what? Right. We're done. Same thing with our normal functions in paper 1. So if I give you example, if I tell you sine x plus 30, what am I saying? I am simply saying sine x has been shifted, talk to me, 30 degrees, where? Left. We're done with P. Please take note, it must be in brackets. If it's not in bracket, it means something else completely. Number 5, Q. What is this? Vertical what? Shift. Q is outside the bracket. Okay, so we have something like x plus 30. Let's put a sign here. Let's put a sign here. Plus Q. It must always be out. So if it's outside, it means it's going up or going where? Down. And what do we know? Upward should be what? Positive. Downward should be what? negative, and Q shows the vertical what? Shift. All right, very important. Q affects the range. Q affects the range. P doesn't affect the range. Let's put that note down. P does not affect both range and period. It has nothing to do with both of them. Q affects the range only. Q affects the range only, whereas P has nothing to do with both. P only shifts left and right. Please, I'd like us to remember these variables. If you remember the variables, we're going to be very fast when it comes to answering questions. Spoke about 5 of them. Started with A. What is A? Amplitude. Amplitude is always positive. Top minus bottom divided by 2. We spoke about B, the number, which affects what? Period. We spoke about what? P. We spoke about Q. And we know which one affects what now. A will affect the range as well.
So it's also domain.
X is the domain. And in most cases in this one, you'll be given. They'll give you X is an element of. All right. Let's do some maths now. We're still playing. We've been playing all along. Let's do something called the range of a graph. These questions are not very heavy. 10, 12 marks. So just understand it. All right. Sia, which 10 note are you referring to? Are we done here? Yes, Sia, which one? Which 10 graph? Which 10 note?
The 10 note, the one between the period is.
Oh, the period of a 10 graph is the distance between two asymptotes. The period of a 10 graph is the distance between two asymptotes. Okay. Now, when it comes to range, guys, I'm good. Like I said, I want to compress this. Give you one formula that will always work. Danger is if you forget it. But we'll do so many examples now. Okay. Please take note of what we said. A is always what? Positive. Even if there's a minus in front of it, that's not A. The minus tells you the graph has been reflected. Okay. Okay, Noe. Are you done? You sure? All right. Period. Let's look at what period is all about. No, sorry, range. We're done with that. Period. Range. Usually the range of a graph is written as minimum value, less than or equal to y, less than or equal to what? Maximum. So let's do it this way. Let's do it this way to make life a bit easy. Function, minimum, and maximum. Function, minimum value, and maximum. I'm only going to do 3 of them, but I'll be compressing the whole thing. So, A sine B x plus or minus P plus or minus Q. what is my minimum? A times minus 1 plus or minus Q. Maximum A times A times positive 1 plus or minus Q. We're just going to throw whatever value we have. So the idea is, can you remember what your A is? Or can you identify what your A is? And can you identify what your Q is? A cos B. Do you notice in the minimum or the maximum, it's only two things that affect it. It is A and Q. Done. B and P. BP. Don't buy petrol. No, sorry. This is just say. They don't affect that, right? So what do we have? A again. It's the same story. The same thing. Maximum. Now for 10 graph. Interesting one here. It is negative infinity to positive infinity. If you can picture the tan graph from grade 10, it goes down and then it goes up. Doesn't matter whether you shrink it, you spread it, you lift it up, you bring it down, it doesn't matter. We're going to start with those little examples, which we know, but I want us to work with them. Sin x, cos x, tan x. Now, if I look at sin x, what is the value of a there? 1. What is the value of q? 0. So if we throw that in there, what's our minimum going to be? What are you doing? Isn't it a calculator? Your a is 1, right? Your a is 1, okay? So if we come back here and put 1 here. What is 1 times negative 1? Negative 1. And our q is 0. So the minimum is what? Negative what? 1. Less than or equal to y. Less than or equal to 1. This is why. I want to explain something to you here. If I tell you to find the value of x, check this. What's the value of x? Please don't tell me you've forgotten how to do trigs. Arcsine. All right? What's your answer? 90 degrees. Check. These are things that must know quickly now. But let's take it above 1, just a little bit. Just a little. Just a little. Check how little I want to take it. That's how small I want to take it above 1. What are you getting? You must get an error. We are saying that graph should not go above what? 1. Maximum. It should also not go below what? Negative 1. You can imagine how little we took it. 0, 0, 0. In fact, I should have added 4 zeros. 1,00001. Automatically you get an error. What about cos x? A is 1, right? Q is what? 0. It comes out to the same thing. If you remember, we're doing this under general solution. While tan would be what? Negative infinity. All these ones are simple. Here we're still playing. This is grade 10. Grade 10. Can we start going to grade 11 now? Please. This is grade 10. All right. I'm going to write a few ones now. I'll start with the first one or two. Then I'll give you about 5 or 6 to run through for me. Please run through. You have this table already? Run through as fast as possible. Yes, look, are we done? They're important. But you'll catch up. It's the same thing. Look at this. Number 1, we're writing the range, right? Let's start like this. 2 sine x plus 2. I'll do the first one for you. What is our minimum? Look, the first thing is let's identify A. What's our A? 2. What's our Q? 2. So what's our minimum? We said A times -1 plus what? 2. A times -1. This one is plus 2, right? What's your answer? 0. What's the maximum? A times +1 plus 2. So what's our range? 0 less than or equal to y less than or equal to 4. Tell me we're okay? Two cos x minus 3. What is the minimum value? Okay, first we said our A is what? What's our A again? 2. What's our Q? -3. So what's our minimum? A times -1 plus what? Q. What's your answer? -5. What is the maximum? A times 1 minus 3 minus 1. So what's our range? -5, and then you have -1. We're done. Ta-da-da-da-da. All right, you'd have this to do to yourself. Okay. We've moved from grade 10 so fast. We didn't even waste time. 4 minutes. The way we jumped into grade 11 and grade 12, it was too fast. Use the table. It's the same story. Can we mark? Talk to me. What's your answer for the first one? 2 times minus 1 will be what? Minus 2. 3 minus 2? 1. So it's 1 less than or equal to y. Is that what you have? Number 2, same thing. I just turned the graph upside down, which still doesn't affect the maximum or the minimum. All right? What about this one? It's going to be 2 to the power 2 times negative 1. Remember the minimum? 2 times negative 1, negative 2 plus 1, negative 1. Less than y, less than, what's the maximum? 3. So what's your answer? 1 over 2 less than y, less than or equal to 8. So you still deal with this one the way you're supposed to deal with it. It is 2 times negative 1 plus 1. 1 minus 2, negative 1. That's the minimum. Then 2 times positive 1 plus 1 will give us 3. That's the maximum. So it's just a way of just playing around with things, but the examiner still means exactly the same thing. Let me know if we are okay, guys. I want to go to sketching a graph. Sketching a graph. Everybody okay? No question. Those of you here, are we okay? It's the same story, same story. Please don't forget in number 4, what is your A? Your A is still what? 2. And your Q is what? The minus only tells you the graph has been what? Reflected along the y-axis. Keep y. No, along the x-axis. Keep x and change what? Y. But A is always positive. Are we okay? All right. So we'll start seeing questions now and start playing around. But let's quickly learn how to sketch a graph. Look, are we okay? Sketching a graph. Sketching a graph. Here we're going to use our calculator to sketch. We're going to use our calculator to get the value. So we'll talk about calculator. What do we press? We press mode. So it'll give us 3 things. We choose table. Once you hit the table button, you get f of x. And sometimes you get g of x in some calculators. You just type the equals to, you type the formula in. I'll be showing us how to get the x. From there, you have your start. This is your domain. You have the end. Also, this is your domain. Domain beginning and domain ending here. Then it will give you steps. This is the key thing. Steps is the main one. And I want to look at how to get the steps. Why is the step very, very important? Why is the step important? It is important in helping us get the correct turning point. And also helps us getting the correct x-intercepts. Once these two are not in, we'll be guessing points. Once those two are not in, we'll be guessing points on turning point and x-intercept. So there's a mark for turning point and there's a mark for x-intercept, which means your step alone carries how many marks? 2 marks. Huh? It's so little. No way. Sometimes it's even 1. I know, once you know it, you want 10 marks on steps. All right, function. Sine kx and cos kx both share the same step, which is 90 over k. While tan kx has 90 over 2k, or 45 over k if you want to put it in another way. Sine, cos, and tan. X plus or minus 30, x plus or minus 60. Our step will be 30 degrees. Sine, cos, tan, x plus or minus 45. Our step will be 45. So what affects your step? Oh, by the way, you know what? Let me do this. So I want us to maintain, sorry. Let me do this. There's nothing wrong with what I did, but there's nothing wrong, right? It's still B and K. But since we used B earlier on, let's keep it as B. So these affect our step. What affects the steps? B and K. Or B and P rather. B and P will affect our step. Interesting. There's something that I'm thinking about right now. Interesting. I want to test it out. Wow. Never thought about it. It just flashed my mind. I'll test it out. Test it out. Which one takes more preeminence? Is it B or P? Interesting. Never thought about it. Just crossed my mind. In the meantime, let us sketch. I'll do an example, guys. We jump straight into questions. Okay? One example, or maybe 2, and we jump straight into questions. Point of intersection in this case, what do? We equate. So point of intersection is basically general solutions. Every time we see 2 graphs intersect, to get that point is basically what? General solution. Can we draw? Okay, example. Let us sketch the graph of f of x equals to 2 sine x plus 30 plus 3. Where x is an element between negative 180 and positive 180. What's your step? That's the first thing you check. What is your step? Your step is 30. It's the one in the bracket. Oh, will this be too long though? It's fine. Step is 30. So, I'll have that. When I say step is 30, it will be long though. 30, 60, not long, 90. What's the next one? 120, 150, and 180, and then we reflect it. Negative 30, negative 60, negative 90, negative 120, negative 150, negative 180. All right, and this graph will be shifted. So, can we quickly get the range? Everybody, get me the range here. Let's see something. This will help us to see how to plot our graph top and bottom. Let's do it manually first. We did that earlier on. Range. Come. Between? You sure? Because that will help me quickly see what my graph would be. Yeah. 5 should be the maximum. Do we agree, everybody? Confirm for me. And you see the importance of what I just did right now. Yes, what's our range? Between 1 and 5, right? Are we getting that? What did you get, Patu? What did you do it? But here's the minus 1. How does the minus 1 come into play? 2 times minus 1 is minus 2. Minus 2 plus 3. I'm waiting for an answer. What's the answer? So, it means my graph minimum value is 1. So that's why I'm dropping my x-axis to help me see. Okay, we're going to confirm that though. All right, with our graph. 1 less than or equal to y less than or equal to what? 5. Let's see if we are correct. Let's grab our calculators, everybody. Please don't get left behind. Right now, grab your calculator. You have your notes. What does the note say? Mode. Table. We should all be pressing the same thing now. No one is left behind. F of x. We type in that function. It is 2 sine. Now, a lot of you have not used the x before on the calculator. Today will be your first time. Write it in your diary. X is written in pink. X is written in pink, so it's alpha, not shift. X is written in pink over the bracket, right? So I'll press alpha button and press my check there. Please find it. Let me know if you are lost there. It is alpha and the X bracket. It's because you pressed shift before. Plus what? 30, we close the bracket. Then plus what? 3. We good? What is our start? Where are we beginning from? Negative 180. That's your domain, the beginning of your domain. So we type negative. Some of you, it gives you g of x. Just press equals to. It means your graph you can plot 2 at the same time. Start, negative 180. Are we there? Yes, Luke, what's the story?
One step.
Relax. And 180. What is your step? We spoke about it. This looks like one of the graphs on the table. It says when you have it as x plus 30, what's your step? 30 equals to. And you have something that looks like that. if you check your y values, let's just play around the y values. 2 there. I want to find the maximum and minimum. All right. 1 looks to be the minimum so far. 2, 3, 4. So we are correct. 5 is max. And 1 is the minimum. Okay, we're going to sketch. Take note of those values. Now, lady, where are you lost? The steps are right on the table. Did you write the instruction down for the steps? Calculator, you see. Okay, you just follow that. Mode, table, f of x, start, domain, and mode, table, now we of the given. With the end step. Are we on the same page now, lady? Talk to me. Can you guys hear me? Talk to me. I'll repeat quickly again. We follow the instructions here. Mode, table, f of x, start, end, and step. Clean your calculator. Clean your calculator, switch it off, switch it on again. Let's take it back to normal. Clean calculator. It's very simple. It's something you do in 5 seconds. So if you are lost, I'm giving you a chance to clean your calculator, switch it off, switch it on, make sure it's a 0 on your calculator. I think if you press A, is it on? Everything should go away, right? Okay. What do we press? Follow the steps. Mode. You have comp, start, and table. Today we are using what? Table mode. 3. Automatically gives you f of x. What's our function again? 2, sine. Look, if I want to press any of these letters, I can press them. I can press A, B, C, or D, but we are using x. Okay? Because the calculator recognizes that as my domain. It did not say f of A. Do you see that, right? If it says f of A, then I can press A. But it says f of x. So I'm only allowed to press what? X. Alpha and brackets. See, if I didn't press alpha, it gives me bracket only. Okay? If I press shift. Now lady, you don't know how to use your calculator. Alpha, it's in pink, so I go for the pink one. Close the bracket. No. There's plus 30, right? Close the bracket, plus 3. What do we have? Equals to, our start is, they'll give you that domain anytime they want you to sketch. Okay, negative 180 and positive 180. What is our step? 30. I gave you a table, just follow it. Boom. Are we okay now? Okay. Are we okay now? All right, I'm getting more people. Yes, Naledi.
The alpha.
Huh?
alpha x.
Yeah. What's wrong with it?
Can you please go back to the, because I got lost after that.
What's your calculator showing now?
F of x equals to 2 sine x.
Yeah, the equation is x plus 30. So plus 30. Did you press
Yes, sir.
close the bracket?
And
Then plus 3. That's the function I gave you.
yes, sir.
Yeah. Equals to, what do you have?
G of x.
Press equals. I told you the g of x means you can sketch two graphs, but right now we're sketching only one. Just press equals to. What do you have?
It's showing me start.
So what's your start?
It's giving me 1.
What's your start on the domain I gave you?
It's 1.
Never. I gave you a domain. Child. I gave you a domain. That is your start. And that's the end. You're telling your calculator to start taking readings. The first value of your calculator should be, of your x, should be negative 180. Come, talk to me.
So I started, gave me 5.
Yeah, end. On the board there, what's the end? Where's your domain end?
It's 180.
Good. And what's your step? After pressing that, you would see step.
Yes, sir.
Look at this table of steps on the board. Your graph definitely looks like one of them. The function we are dealing with looks like one of them. Which one does it look like?
The one with 30 degrees.
So what's the step?
Plus 30 degrees.
That's your step there. So press the step. Equals to.
Oh, it gave me a table.
We're done. It's that easy. It is that easy.
Oh, thank you, sir.
All right, cool. Guys, give me, so we'll all compare our values. When x is negative 180, what's your y value? Please let's all compare the values together so that because my own calculator disappears once I start talking to you. You said it's what? 2. Okay, so because we don't have a grid, negative 150, 1 comma, 27. Okay, which is about 1,3, right? So we're just going to estimate that value somewhere there. That's 1,5, 1,3. We're just going to estimate there. All right.
So if we have to go to minus 1
No. Just we need to see that. We need to see that mark. We don't skip it. 120. 120. 1. I hope we are all getting the same value. Negative 90. Huh? 1. 1,3. Is it the same as the 1,27? Yeah, so it's the same level, right? That's the same value. Negative 60. Negative 60 goes back there as 2. Negative 30. Negative 30 is 3. 0. 30, 4.73, which is close to that, right? 60. Look, you're not even sketching. 60 is what? 5. You want me to wait for you again? 90. Same value as that other one, I believe. And 120 would be 4. And 150 would be 3. Right? And 180 would be 2. Am I right there? Then we have our graph. That please don't use a ruler. It's a parabolic nature graph. And that's our graph there. That's our graph. Let's put a dot there to make sure that it's included. You see, I'm not using arrows here, like of normal functions. Why? The arrow tells me my domain is from infinity to positive what? Infinity. But here, can you see, it's negative 180 to 180, and those values are included. How do you show inclusive? Circle and shaded. Very important. Okay, please, we okay? Once we sketch like this, we can tackle, a question. And if you check our domain, our range, we're correct. The minimum value of that graph is -1, and the maximum is 5. Can we calculate amplitude from here? Let's check. What's the formula for amplitude again? Max minus minimum. So we can get, can you see we can get our A from the range? What is the max? 5 minus 1 over, what's your answer? 2. I'm going to go straight into exam questions. Let's see what these examiners will be all about in terms of answering a question. The truth is, if you understand what we did right now, then reading from a graph becomes quite easy, because you know how they got that graph in the first place. We good? So at this stage, you won't be able to sketch the graph. I need you to listen carefully, work things out with me. When we get to a question where we have to sketch, you sketch. Sketching is 3 marks. All right, I'm going to jump. Here we go. Look at this graph, everybody. Look at this graph. I didn't want to put the question on the same page with the graph so that it's easy for us to see the graph. The sketch graphs below are sign AX. Look at where their A is. This A doesn't mean amplitude, please. It's just a letter there. That talks about the period. It's now our own B. Are you there? And G of X is what? Cos X minus B. Do you see? It means that one has been shifted. Okay? All right. Do we have letters for this graph? No. But we can always guess. We can always get the one that is F. The sine graph, this is F. And this is what? G. Okay. My beautiful learners, look at the question. Determine the values of A and B. Let's come back to the graph. We're looking for this. The number before the X, which is our own B, what did I tell you it does? Tells you the number of graphs in what? 360. I'll show you 2 ways of getting this value. Either you count, if you can count. Let's look at this graph. Wait, what do you notice? That's one full cycle there. And what is the length? 180. But we said it must be in 360, right? Let's check something. If we look at 360, from here to here is 360. How many graphs do you have? How many? 2 graphs in 360. So that value is what? 2. Does that make sense? Another way to do it, please watch this. Let's look at one full graph. What is the length of one full graph? 180. I gave you a formula. Do you remember the formula? It says period is equal to what? 360. This time around, I'll be saying what? A. Period is one full length. What is one full length here? 180. Equals to what? 360. I'm sure you can do maths. You're still going to use a calculator for that. Okay. Very good. A is 2. A is 2. So, this graph tells you f of x is what? Sine 2. It means we have 2 graphs in the space of 360. Let's deal with g of x. This is nice. G of x, the graph has shifted. You need to understand, please get back to grade 10 and draw a normal G of x cos graph. A normal cos graph should have passed through this point, because 0 is 1. But check something, my beautiful learners. Do you notice this graph? A normal cos graph should have come this way. But, and turn here, and go to 90. But this graph has gone backwards. It has gone to the left. If it's shifting to the left, what should that be? Positive or negative? It's positive. Okay. But the issue now is we do not know the number of shifts that is there. This is why it's important, I should have actually started that way, for you to know the cos graph, original cos graph. It is very, very important for us to know the original what? Sine graph, original cos graph, and original tan graph. But I figure out you'll be able to do that from grade 10. Okay, but we'll look at it again. But how do I get the value of b? Take note. Let me do this. So I'll be able to see that graph. I want to show you something very nice. Usually I use the positive graph, but I don't want it to get, for me I already see my value, but I don't want it to behave like me. I want us to work it out. Look at this graph. What is that? That's my x-intercept there. And y is what? 0. Make sense? Okay, so y equals to cos x minus b. We okay? What's the y value at that point? 0. Sorry. Yeah. And we have what? Cos. What is x? Negative 120. I know it's 30, but let's see. Now check. How do I remove cos there? I look for the arc cos of both sides. Arc cos of 0 is what? What is the arc cos of 0? Really, guys? 90 equals to what? I want to show you something here. This is quite tricky. Usually, I like to move it, work with the positive side of the graph. But I want us to see something here. Let's move this over. What are we going to get? 270. Right? 270 equals to what? But listen, this thing here, in most cases, should be acute. 210. How do I make it accurate when I have a 210? Never. Subtract from. So B is what? Negative 210, right? In order to make it accurate, wait, I just add 180 to it. I just lost you there. It means we have forgotten our quadrants. 180 plus theta, 180 minus theta. So for me to get 210 from 180, what would I say? 30, right? Good. And I notice that this graph is shifting where? To the left. If it's shifting to the left, it has to be what? Positive. By how many units? 30. You can even see it. It's very clear. So B is what? 30. You'll get to see this graph. Guys, before I go on to the next question, let's pause. Let's draw the mother graphs. Let's draw the mother graphs. You cannot use reduction here because we don't even know what B is. Quickly, let's draw our mother graphs. Everybody, very fast. Mother graphs. That will help us quickly. Mother graphs. We're going to be very fast. Mother graphs. We're going to use theta being between negative 180, and we write the important parts. So we start with sine theta. Quickly, everybody. Sine theta. Let's draw our mother graphs because I know that some of you were lost there. 0. We're drawing sine theta. F of x equals to sine theta. What should be our domain? What should be our step? 90. 90, 180, negative 90, quickly, what is sine 180? 0. What is sine negative 90? Minus 1. What is sine 0? 0. Sine 90? 1. 180. So that is my sine graph. Mother graph. I missed my turning point. Please take note. What is the turning point here? 90 and 1. What's our turning point here? Negative 90. Are we okay? And negative 1. My x-intercept? Negative 180. 0. What is this? 180 and 0. And here? Those are the key points that we need. Intercept and turning point. Those are the key points that we need. Why don't you mark those points? You see? Negative 90 and 1. Mark it. I mark it first before I start joining. 90 and 1. This is not your 1. Look at where your 1 is. And you can look at where you put your 1 here, between 1.5 space. And here is just 1 space. Try to make it a bit, equidistant. So please always put the mother graphs at the back of your mind. It's going to make life a lot easier. Okay. Especially turning points, intercepts. Let's draw cos. Please let's mute ourselves. Let's mute ourselves. Let's draw the graph of cos. Cos theta. And I'm going to show you something tonight. Oh, there's still time. Next week we'll answer questions. Cos theta. Mother graphs again. Cos theta mother graph. What is cos 0? Sorry, cos 180. negative 1. No, I'm on, that's cos negative 180. Cos negative 180 is 1. Just check. No, it's negative 1. Just check on your calculator. Because cos negative 180 is anything as cos 180, which is negative 1. Right. Cos negative 90? 0. Cos 0? 1. Cos 90? 0. Cos 180? Negative 1. Ooh. So your graph looks like that, and then it turns there. It turns right there. It should be turned. Ooh, I'm going to clean that. I knew it. What's a going? There we go. What are the important points? Where is it turning? Negative 180 and negative 1. Intercept? Negative 90 and 0. Here, x is 0, y is 1. Intercept? 90 and 0. Turning point? 180 and what? Mother graphs. It helps to know the mother graph. Just helps. But we can answer the question without the mother graphs, but it's faster when you have your mother graphs at the back of your mind. All right, everybody good? 10 graph. 10 graph. 10 graph. This one is a special one. 10 graph. I'm moving quickly. 10 graph. F of x equals to what? 10 theta. What's our step? Stop line. 45. Remember, it's 90 over 2k. 2b. And our b is 1. 135. 180. Negative 45. Negative 90. Negative 135. And negative 180. This one, you don't even need the table. You can just type it in quickly. You can just type it in quickly. What is tan 0? 0. Tan 0 is 0. Tan 45 is 1. Tan 90. Check on your calculator what it will give you. It's an error. And that tells me that's where my asymptote would be. What about tan 135? Negative 1. Tan 180? 0. What is tan negative 45? Negative 1. Tan negative 90? Error, which gives me my asymptote. Tan negative 135? Is that 1 or negative 1? 1. And tan 180? 0. Negative 180, 0. So, your graph moves close towards your asymptote, but never touches your asymptote. And you can see the range here. Negative infinity to positive what? Infinity. All right, so the mother graphs, keep them at the back of your mind. And once you see a graph, just quickly put the mother graph side by side and see what's going on. Quickly, side by side. And then the other calculation I'm doing, I'll show you as well. But that calculation works best if you choose an angle between 0 and 90. Works best between 0 and 90. That graph was not well drawn, but they expect you to know your mother graphs. So can we go back to answering our questions? All right, so this is the mother graph. Mother graphs. Okay, let's go back. So here, we said A is 2 and B is what? 30 degrees. So that you can see your graph, f of x is what? Sine 2x, and g of x is what? Cos x minus 30. The graph has shifted. Do you notice that turning point there? And this is what? Negative. But it is shifting to the left, which means we have what? Did I say minus 30? Yeah, minus means what? To the right. For it to shift left, what are we saying? It has to look like this. So B is negative 30. Interesting. The examiner is very tricky there. Very cheeky one. Makes sense? The graph has shifted to the left. So in the bracket, we must have it as a positive. So please take note of that cheeky examiner there. X plus 30. So A is 2 and B is negative 30. We'll get to do more of this and see how to work it out. To use values, usually I use between 0 and 90. Is that okay? Between 0 and 90. But the reason I chose to use the negative 120 is because there's no clear value here between 0 and 90. Make sense? Okay. Let's see. Next question. Determine the coordinate of C, the turning point of g of x. C. Where is C? At the bottom there. At the bottom. Here. There are two ways of doing it. Mother graph, you can observe. This is a cost graph, right? And we want the turning point there, right? What's our y value? Negative? Negative 1. The question is, what is the x value? Don't forget, this graph has shifted by what? 30 units. So you shift all the mother graph values by 30. But in case you don't know the mother graph value, let's see something. Let's work it out. What is, you can work it out. Our g of x is y value, right? So what do we have? Negative 1 equals to what? Cos x plus 30. What do we say? Cos of, arc cos of negative 1 is x plus 30. What is the arc cos of negative 1? Really now? But it's fine. Use your calculator. It's nice. What do you have? 180 plus 180 equals to what? X plus 30. What is x? 150. So what, and it makes sense. It's between 135 and 180. So what do we have? What's the turning point? 150 degrees. And what? Let me know if we are okay, everybody, quickly. If there's any question, let's handle it now. Any question? Awesome. And if I take you to the mother graph, let's go back to the mother graph and see something. Where was our turning point? Can you see our turning point? Look at the turning point, 180. shift it to the left by 3 units, 30 units. It comes to what? 150. So if you know your mother graph, it's always easy. But if you don't know your mother graph, you just do your normal trig values, you get your answer. Okay? For which values of x, where x is what? Less than 0 is, we go back to paper 1. F of x multiplied by what? G of x greater than or equal to what? Let's start interpreting from the right hand side. If it is greater than 0, this must be what? Positive. We're multiplying two things, right? For us to get positive, what should we be multiplying? Positive and positive, or negative and negative. This gives us greater than 0. Make sense? But they also said it must be equal to what? For it to be equal to 0, since we are multiplying, it's either this 0 or, make sense? 0 multiplied by anything would give us 0. So you start interpreting from the right-hand side. Greater than 0 means we want it to be positive. How do you get positive? Multiply two positives or multiply two negatives. Then they said also 0. It's either f of x is 0 or g of x is 0. My beautiful learners, we go back to our graph. Remember what f of x is. F of x is what? Y. What is your y value here? Negative. 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 What's your y value here? 0. That 0 looks to be very gigantic. Okay, so negative, negative. What's the y value? 0. What's the y value here? Positive. 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 What's the y value? 0. What's the y value? Negative, 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 negative. Let's use a black one. What's the y value here? Positive, positive, positive. Reason why it's positive is above, right? What about here? 0. Here? Negative, 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 negative. Here? 0. Positive, 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 positive. 0, negative, 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 tiv, 0. What are we looking for? Go back to the question we analyzed. Where they are both positive or both. Basically, we're saying where are they both above the x or where are they both below? Straightforward. Come, let's think. I'm going to use a green marker here, a straight line. And let me get a bold one. I'm going to be moving this. What signs am I touching? Black positive, red negative. But what am I looking for? Same signs. Tell me where to stop. Ta 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 da 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 ta 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 da 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 da. All right. I should stop there first. Why? There's a 0. And I need that 0. Make sense? Okay, so that point is there, which is what? Negative 120. Okay, do I need this point? Why not? No, I need it. The red is positive, the black is positive. I need all of this point. Up to where? There. Why there? Once I move from 90, what am I touching? Positive and negative. But what do I want? Positive and positive. Can I first mark out my answer first for this one? Do we agree that we need that point? Can we continue? All right. Stop. Okay, let's check. Yes. Both positive, right? Stop. That's a 0 there. Once I pass that 0, what happens? Positive and negative. So can I mark my point again? I need where both of them are positive. Do we agree? Okay. Positive and negative. What do I have? A 0. And after that 0, what do you notice? Both are negative until 180. Okay, so do we agree that that's part of the answer? How many answers do we have? 3 answers. Let's check the mark. 3. Makes sense. What are our answers? Between negative 120 and negative 90. How do we write it? Don't forget, this is how we write our mathematical between. If I were to write a book, that would be the book cover. This is the book you need to move between failure and success. So I just want to put that word between. All right. I've been writing my maths book with my mouth. Hey, God. I'm telling you. With my mouth. All right, what do I have? I've started, but too many things to do. Negative what? 90. What's the second one? Do you notice that point there we don't know? This examiner, tricky. Can you tell me what that value would be? Do you know, we don't know this value. Let's call this K. But what do we know about it? It's the X what? Intercept, and Y value equals to what? 0. Let's do it manually, and let's go and look at it graphically again. We know that this is, what graph is this? No, stop lying. Oh, it's a cos one. Okay, sorry, I'm lying. Okay, what do we have? Y equals to what? Cos X plus 30. What is the Y value? 0. Cos X plus 30. Can we say arc cos of 0 is equal to what? X plus 30. What is the arc cos of 0? 90. So 90 minus 30. What is X? Let's prove it. Mother graph. So this is somebody who doesn't want to use the mother graph. Somebody who wants to use the mother graph would remember this. Do you notice that where's our x-intercept? 90. And we moved what? 30 units. 90 minus 30? 60. I'm showing you both ways. Either by mathematics or by mother graph. Okay, so K is what? 60. So we said between 0 and 60. Should have been 4 marks actually. Because that 60 should have gotten you a mark. And the last one? 90 and 180. Please talk to me. Let me know if everybody's okay. Thank you, Tsepang, for giving me that 60. Oh, I didn't tell you. There's something I should have told you. It's fine. I'll deal with it here. We said the graph can be shifted, right? The axis can also be shifted. Let me make you see. Let me make you see it quickly. For 8.4, let me deal with something for you. Please, everybody. I want us to deal with something. It's part of content. All right. Part of content. We'll come back to 8.4. Look at this graph. I'm working with the sine graph. Okay, that's our graph. Right. Good. If I ask you to draw this for me, g of x, and I say, let us shift this graph. Please, I want you to listen to me. I'm doing 2 things here. 90 degrees to the left. What will it be? Theta? Huh? Plus 90. What will this graph look like? Okay, hold on. I think I can. Is my mouse working? This will have been nice. But it's fine. Let's shift every point that we see here 90 degrees. Which means this 180 here would come here. This 90 would come here. Do we agree? This 0 will come here. Make sense? And this 180 would move there, right? Good. So what should our graph look like? Huh? Do we agree? Make sense? Are you okay? I don't know if you see something here though, but it's fine. What did we do, my beautiful learners? We shifted f of x 90 degrees to the left. Please listen to me carefully. I don't want you to get confused. Is there another way I could have achieved this graph by shifting the axis? Yes. Please listen carefully. If I remove this, I'll add the note to it. Wait, before I remove it, do you notice where my turning point is? My turning point is at 1. And what? 0. Can I achieve that here? By shifting the axis. Where should I shift the axis? Does that make sense? I lost you. Yeah, talk. Don't try to figure it out. Talk quickly. Look at my graph again. Please look at my graph. Maybe I shouldn't delete it. Or let me, I don't want to get confused. Look at the green one. Look at the white one. I want the white one to now look like the green one. Look at the highest point. I want you to see this point. This point is this point. So I want the y-axis. I want this. Okay, let's do this. If I do this. Do you notice basically I am saying shift the y-axis where? To the right. Or shift the graph to the left. It's always opposite each other. Shift the y-axis to the right means the graph has shifted to the left. Let's go back here quickly. Horizontal shift. Let's add that note. P represents a horizontal shift. When it's a plus P, it means the graph is shifting to the left. But what does that mean? What are we going to say? The y-axis shift where? To the right. Here, the y-axis does what? Shift to the left. Please add that note to it. I'm glad we came across this question. Otherwise, you'll be saying it's a mistake in the exam. Google. All right, I'm going to go back to it now. Yes, Google. Okay, yeah, that's why it's 3 marks. Google just reminded me of something we neglected. I'll go back. Thanks, Google. But are we okay? I think I got too excited by that question and I forgot the instruction. Yeah, I got too excited by it. Forgot the instruction. Are we okay with the shift though? This is where Google is bringing my attention to. I really got too excited. But it's good we looked at it that way. They gave us a restriction on that question before we go to the last one. For which values of x, where x is less than 0? We just wrote all the answers. X must be less than 0. Which one is correct? Only the first one. Only the first one. Thanks, Google. All right. Determine the graph equation of f of x if the y-axis moves 30 units to the left. We want f of x, right? What is f of x again? Sine 2x. Now, if the y-axis, remember, y-axis moves 30 units to the left, 30 degrees to the left, what does that mean? It means the graph has shifted what? 30 degrees to the right. And if it's shifted to the right, what is it? If the graph is shifting 30 units to the right, is it a positive or a negative? Huh? It's a negative. So what are we going to write? F x minus 30 will be equal to what? Sine 2. Please take note. I told you it must always be in the bracket. And it's not the 2. It's only the x. Please take note. The 2 stays outside. It's only the x. No, we said graph 30 to the right. I'm already talking about the graph. Remember, y-axis 30 to the left means the graph itself is moving 30 to the right. And if it's the right, it's minus. We've already changed the sign. Guys, are we okay? Let me know. 8 marks. Like I said, these questions are not so long. It's 8, 10. Maximum you have is 13. I doubt. Let's see. I know time is running out. Let's check something. Let's see this one. Oh, I love this. I love this. Sketch below is a graph of x cos x over 2. Interesting. X lies between negative 180 and 180. I can promise you the question here is, what is the period? What's the period of this graph? Sorry? What is the period? I need answers. No one is going home. This class finishes when you get me the correct answer. What's the period of this graph? (360). What is the period again? Period is one full graph. Is this graph full? This is half a graph. 720. You didn't say 720. Maybe you said it in your head. It's not 360, Bonolo. It's 720. 720. Can you see that this is half? By the way, the examiner is just playing. That means you guys don't know math. This is written as cos half x. And I told you, period, since it's a cos graph, is 360 over b, which is 360 over half. And that is what? 720. And if you don't want to use that, look at the length of the graph. This is half. Where's the other half? Somewhere there. So if half is 360, the other half will also be another what? 360, which gives me my total length of 720. It does. Huh? Upside? No, because 0 is 1. Check. That's the shape of the cos graph. Cos. All right, for f of x, quickly, write down the range. What's your range? Ooh, this examiner is... Range. Remember, guys, they gave you a restriction. Don't go and start writing your own things. Your answer must lie between that. What's the minimum of this graph? 0. Right? And what's the maximum? 1. We're done. We are done. So we've already answered the first 2 questions. 0 less than or equal to y less than or equal to 1. What is the period? Come, let's answer this one, then we go. Draw a graph of x sine x minus 30. What are we saying? Don't even stress. What's your step? I need your calculators quickly, everybody. I need those values. Mode, table, f of x is sine x minus 30. What's your start? What are you typing? Is that what you do in the exam? Huh? That's what you do in the exam. Continue. What's your step? 30. All right. We ready? Okay, so we're sketching on the graph. Quickly, negative 180. Sorry? Positive, right? So which is somewhere in the middle, exactly in the middle. 150, negative 150? 0. 120? Negative 0.5. Okay. Negative 90? Wait. Hold on. Negative 120 said what? Yeah, negative half. Okay. Negative 90? All right. 87, which is close to negative 1. And then negative 60? Negative 1. All right, that's all I need. Are we fine? When it is 0? Negative 0.5, right? We good? 30? 0. 60? 0.5. 90? 120? Oosh. 180 is? Okay, I'll fix it when I get there. $180 is half. I want you to see something, guys. By doing that, how many marks have you gotten yourself? 4. Clearly show all it. Do you notice we are not guessing the turning point and we're not guessing the intercept? We actually got those points. We know the exact point. We know where the graph is turning. Once you see that you don't have a mark on the intercept, something is wrong. Because you'll be guessing that value out. But here we got, can you see, we marked it. So these are the important points when you sketch a graph. Please take note of these important points. That is important. 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 Once you see that one or any of those graphs are not there, something is wrong. Any of those points, you are guessing that value. Okay, 4 marks. For which value is f of x multiplied by g of x? Let's answer that as we close, and I'll give you questions to do for me. F of x multiplied by what? G of x greater than or equal to 0. We start from the right-hand side. Greater than or equal to 0 means positive. What are we looking for? Both of them being positive. Both of them being negative. Either of them being what? A 0, because it says equal to 0. We're good. Come quickly. Let's run. And talk to me. Plus. Oh, this one is just plus. 0. Red. Plus. Okay. 0 there. Negative. 0. Positive. What are we looking for? Both positive, both negative. Okay. Do we have the first answer? Between negative 180 and negative 150. Do we agree? Talk to me. Do we agree? Okay. I don't need that one for today. Finishing now. Do we agree there? Okay. Where else? Check. Between? All right, so what's my answer there? 30 less than or equal to x less than or equal to? Game over. How many marks is this? Total question? 10. So if you don't get this one right, it's not me, it's you. Those of you at home, please take screenshots of this. Take screenshots and send on the group. They'll send on the group, don't worry, because if you take pictures from here, these lights are always reflecting. Please, those of you at home, Naledi, Sia, Gugu, Jada, both on the grade 11 and on the grade 12, take pictures. Sia, the equation for period will be b is half, and then we multiply 360 by the inverse. No, we just divide. Sia, we just follow my formula, 360 over b. Take pictures.
So can you please send me the number of x for the number for How was your Sunday service?
Take a picture here. Take a picture of this as well. I hope you're getting them, Naledi, or whoever is taking for grade 11 and grade 12. Take a picture here. And before you take a picture of this one, just want to write something. Sine 2x. I want to make it doable for grade 11. Sine 2x is the same as sine 2 sine x cos x. Yep, now take a picture of it, and we are done. Thank you, everybody. If you got those pictures, let me know, and have a lovely evening. All right, thank you, Kian.
Hi, sir.
Tsepang, yep.
Yes, sir. Will you please go back to the slide that we were working on of the graphs? The last slide.
The one we did.
Yes, sir. Please.
Of this one.
Yes, sir.
Okay.
Just gonna do it.
You are most welcome. All right, that's it. Yep, Naledi.
Can you please go back to the second slide, the one that we're taking pictures of?
All right, let's see. I'm not sure which slide. Did you get this one?
Yes, I got this one.
This one?
This one. Yes, sir. This one.
Okay.
And the last one, please.
The last one?
Yes, sir.
Bye, Google.
Thank you, sir.
All right. Bonolo, which page do you need exactly? First page of the notes. Second page of the notes. Third page of the note. Fourth page of the note. Examples. Sketching a graph. Okay, that's are the notes. Awesome. Those are the notes. The rest is just mother graphs, sine theta, tan theta, shifting of the graph, and that's all. Awesome. All right, guys, have a lovely evening. Keep warm. It's cold. Bye, guys.